Okay. Two angles that share a common vertex and a common ray or a common side. Okay. We will see the diagram of it and we'll see how that is formed. Vertex and a common side. Okay, so they are basically side by side. We can say they are side by side. Okay, now let's draw them and see. In this angle, I have a line segment AB, AB, okay, and let's name it CD,
BCD.
okay. So now you can see that C, D, and D, all the rays are joined together from the point A. Okay, so in we are making an angle with the D ray, C ray, and A vertex. Okay, this is the vertex. A point is my vertex. Okay, and B and D are also originating from the A point. Okay, and in what is common in CAD and BAD, D line, that is common. This line is,
Ma'am, the D ray and the A point, ma'am.
yes, common. Okay. So this angle and this angle, okay, angle CAD and angle DAD are adjacent angles. Okay, they are adjacent angles.
Done, ma'am. Done, ma'am.
Okay, okay. So next we will see. Next one we will see complementary angles.
Ma'am, complementary is add up to 90.
Right. Complement. Two angles whose measure is 90 degree or whose sum is 90 degree. (90°) are complementary angles. Okay. Now, let's take an example. I have a line segment. Okay.
Okay, ma'am.
And here is my angle, one angle, and here is my another angle. Okay, now measurement of this upper angle is 60 degree. Okay, and this lower one is
30.
30 degree. Okay, so let's name them. Let's name this point O. Let's name this point
Ma'am, thank you for naming the point O. I love the word O point. Thank you for naming the point O.
A, B, and please write it down O. All right. So now what will be the names of the angles? The 60-degree angle will be angle AOB will be 60 degree. Okay. Then we have angle BOD which is 30 degree. If I add them AOB plus BOD, their sum will be 90 degree, which means that they are a pair of complementary angles. Okay. Complementary angles.
O point, A point, B point, C point. Ma'am,
Okay, Abraham.
I have a
Yes,
question, ma'am. If
yes.
they are complementary angles, then why are the why are they not in? Why are they forming acute? Why are they in an acute?
Why are they in an acute? Um, See, Abraham, this is not one angle. Okay, acute is a single angle. Okay, these are two angles together. They are a pair of angles. Okay, they are a pair of angles, and any pair of angle, acute, obtuse are single angles. Okay, now we are talking about pairs of angles. When you're having such a pair whose sum is coming to 90 degree, means that they are known as complementary angles. Okay, because it is in a pair now. So we will call it this pair of complementary angles. Okay. You are saying something? You are muted.
And basically, you do 60 degrees and then you drew a line in between and put that 30 degrees. Right, ma'am?
Basically, I
So if
basically
you
yes, I did that.
and if you remove line B, then it'll only be 30 degrees. Say 60 degrees.
If I remove line D, it will be 60 degree. No, then it will join 60 and 30. If I remove the B, if I remove the D line, then it will be 60 degree. Okay, see, look here. Look here.
I'm still not understanding now. If 60 plus 30 equals to 90 degrees, then why is it
Mm-hmm.
not a 90-degree angle?
Why is it not a 90-degree angle? Because two angles are forming here. Okay, like two angles are forming. This is a pair, Abraham. We are talking about pairs of angles. Okay, we are talking about pairs of angles. Okay, two
But
pairs of
ma'am, 60 plus 30 equals to 90, ma'am. And if a 30-degree angle is drawn, ma'am, first of all, the 30-degree angle will be a little bigger, ma'am, I think so. But then why is it not equal to a 90 degrees? And why is it equal to like a smaller than that?
This is, I have not drawn it with the perfect measurements. This is for an example. Okay. This is to give you an example. All right. And if you draw 30 and 60 with a perfect measurement, it will be equal to 90 degrees. Okay, it will be equal to 90 degrees. Yeah. Now, hope everyone has done this one. Okay. Next, we will see third one, supplementary angles. Now, in 90, when we add up two angles, their sum is, sorry,
180.
in complementary, when we add two angles, their sum is 90.
90.
But in supplementary, when we add two angles, their sum is 180.
180.
Excuse me, ma'am.
Yes, Anaya.
I drew AOB as 60 and BOD as 30 and I got 90. The full this thing, AOD equals to 90.
Yes, that's right. The measurement will be equal to 90. Okay. Two angles are supplementary angles if the sum of their measurement
Point.
is 180 degree. Okay. Now, let's draw and see it. This part is 60 degree and this part is 120 degree. Okay. So now if we add them, now my angle AOC, AOC is how much? 120 degree. Okay. And angle COD is how much? 60 degree. Okay. If I add them up, I will get 180 degree. Okay. That is a whole straight angle I will get. Okay. A straight angle I will get. So when you are getting the sum as 180 degree or when a straight angle is forming, it will be known as pair of supplementary angles.
Yep.
Straight angle is forming when their two angles are formed on a straight line. Their sum is 180. We have supplementary angles. Okay.
Ma'am, are there any more this one?
Are there any more? Yes, yes, there are more.
I think there's only one more.
Basically, yes, there is only one more, but there is one additional that I want to show you all. Okay. One additional that I want to show you all. Please mute yourself, Frederick.
Okay, ma'am.
Done.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So let's move forward. Now, this is also a part of the types of pairs of angles. It's known as linear pair. Okay, linear pair. Two now in a linear pair, two adjacent angles when form a straight angle, both of their sum is 180.
Ma'am, the same thing as supplementary, ma'am.
Same thing as supplementary, but it is also called linear pair. Okay, the pair of two angles is also
Is
called
it called only linear pair or linear angle as well? No?
no, not linear angle, linear pair. It's called. Okay, you can do a star mark below supplementary and do this. Write this down.
Ma'am, why is it called pair? Not like
Why
angle.
why is it called pair? Because the same thing we have supplementary angle, and it is also called pair because it is forming a pair of two angles on a straight line. Two adjacent angles forming a pair of two adjacent angles on a straight line. Okay, so that is why it's called a pair. Two adjacent angles when form a straight line a straight angle both of the sum is 180 degree and their sum is 180 degrees. Okay, so this is kind of similar like the supplementary angle. Suppose I'm having an angle of 45 degree and one more of 135 degree. Okay, let's name them A, O, B, and E. Okay, so angle AOB is 135 degree. Angle POB is 45 degree. Okay, their sum is 180 degree. And here is where the linear pair is forming. These two are forming linear pair. Okay. Hi, Simeon. Hope you're able to
Hello.
hear me. Okay. Okay, so just let me know once you are done. We'll move forward.
Done, ma'am.
Okay.
Ma'am, just give me a minute.
Sure, sure, Nana. Are you sure? Finish it.
I'm done.
Okay, so
Done, ma'am. Thank you.
done. Okay. Abraham done. Okay. So this is the last one that we are going to see. Okay, the last type. They are known as vertically opposite angles. Vertically opposite angles. Now these are the angles that are opposite to each other. Okay, and they are how they are made. They are made when two lines intersect each other at one point. Okay, so I'm writing it, and we will see how they are made. Angles that are opposite or two straight intersecting lines you can write. Okay. Now suppose I have a straight line going like this. Okay, a straight line going like this. And I have another straight line intersecting this line like this. Intersecting this line like this. Let's name them. This is AB. This is CD. Okay, this is intersecting at point O. Center is O point. Okay, now one angle will be formed here. Angle will be formed here. One angle will be formed here. Will be formed here, and one angle will be formed here. Okay. four angles are formed. Now, what are vertically opposite angles which are forming between the intersecting lines which are opposite to each other? See, this angle, the top one,
Ma'am,
okay?
they all equal to 360 degrees.
Yes, the top one and the bottom one, and this side one and this
Ma'am,
side one. Okay,
I'll tell you, ma'am.
yes,
Ma'am, AOD and COB.
AOD and COB, yes, and
And
AOC,
AOC and BOD.
BOD are vertically opposite angles. Okay, now let's write them. Angle
AOD
Okay, now suppose, for example, angle COD or BOC is, suppose this top angle is 145 degrees, for example, 145 degrees. Okay, then its opposite angle, that is DO, DOC and AOD, right opposite AOD will also be 145 degree. Okay, and if suppose AOC, this one and the side one is 35 degree, 35 degree, then BOD or DOB will also be 35 degree. Okay, this property says that vertically opposite angles are equal. Okay,
Ma'am, it's a rule. It's a rule.
yes,
Yes, ma'am, I
rule.
got 120. AOD equals to 60 and BOD equals to 60, while BOC equals to 120 and so does AOC.
Very good. Vertically opposite angles are equal. Okay, so if I know one angle and I have to find out its opposite angle, what can I do? It will be the same, okay? I can just put the same thing. But what if, suppose, one second. Suppose I only know that this angle is 45 and I have to calculate the rest of them. Okay, I have to calculate the rest of them. So first see now,
Ma'am, can I
145,
tell you do it?
that's,
Can I tell
yes,
you?
Abraham. Yes, Abraham.
Ma'am, first you will tell. So corresponding angles are the same. So 45 and 45. Then we will angles in around a point equal to 360. So 45 as 45 plus what will equal to 360 divide by 2 will get us the answer.
Okay, 145 plus 145. We'll add them and subtract them, subtract the sum from 360 and divide it by 2, we'll get us the answer. That is right, but a little long process. What you can also do is look at only line AB. Look at the line AB. Okay. And angle, one side we know 145, and we know that the total is 180. So we can do 180 minus 145 directly. Okay, 180 minus 145, we will get
Ma'am,
what?
35.
35. So now when this will be 35, we know. So this will also be 35. Okay, and this will be 145 because vertically opposite angles are equal. Okay, so this way also you can do. Abraham's way is also correct, but a little bit long. But like 180, if the two angles are on a straight line, okay, then their sum is always 180 degrees. when two angles are on a straight line or supplementary angles are there, their sum is 180. If you know the one angle, you have to find out the another one. Subtract the one you know from 180, you will get the other angle. Okay, you will get the other angle. So this is how you can do it. All right. Now, math test is tomorrow. Okay, of the fourth chapter, and of this exercise to identify the pairs of angles, I'll be sharing a worksheet. Okay, you guys have to identify that which pair those angles are forming. Okay, I'll share one worksheet in the group. You can solve that, and we will practice questions on pairs of angles in the next session. We'll practice questions on pairs of angles in the next session. Okay,
On
we
Monday?
stop here. Monday, yes. Okay, so we stop here and 5 minutes break, and I'll see you guys in the science class. Okay, Adric, see you tomorrow.
Bye, ma'am.
Bye. Yes, Simeon, any doubt you have?
No, not like that. Wait 1 second. So I can get my ICSE book. 1 minute.
Sure.
Um, I'm not able to solve this question yet. Brijesh lent Akshay 32,500 to purchase a car at 12.5% annum. If the interest is compounded semi-annually, find the interest paid by Akshay after 1.5 years. So the principal is 32,500. The rate is
Can you put it in the
12.5%.
chat, Simeon? Can you put it in the chat, please?
Okay.
Yeah.
I sent the question.
Okay, Simeon. And what do you have to calculate in that question?
Um, Find the
Interest. Okay. Let's try it out. 1 minute. Okay, so you are having the principal 32,500. Rate is 12.5. N is 1.5 years, compounded semi-annually. Okay, so N will become how much? N,
N will become 3 and R will become 6.25.
very good, 3, okay, and R will become 6.25, okay. All right, now we are having the principal rate N and time, okay. So we will first find out, use the amount formula. Amount is equals to principal 1 plus R by 2 by 100 raised to the power 2n. Okay, so amount we don't know, principal we know, 32,500. 1 plus. Okay, now 6 point, what did you say? 12.5 do its half.
It becomes 6.25.
It becomes 6.25. Okay. Also, if we divide it by 100, we can also use 0.0625 if we directly divide it by 100. Okay, raised to the power 3. Raised to the power 3. Okay, now add 1 to 0.0625. So it becomes 32,500
But
and 1.
why do you add 1 plus that? Shouldn't it be like 1 plus 6.25 by 100 and then you get 106.25 and then do that by 100?
Then do that by 100. Yes, Samuel. Or you can just do it directly. Okay, first divide 12.5 by 2. Okay, then divide what you'll get by 100. Okay, divide that by 100. So you get 0.0625. This also you can follow. Both parts are correct. Okay, then I'll add 1 to it. So it becomes 1.0625. Okay, 1.0625 raised to the power 3. Raised to the power 3. Now solve it, Samir. 1.0625 raised to the power 3. Solve this. Write out.
I got 1.1994.
That's right, Sunil. 1.1994. Okay, now multiply it with 32,500. You are also getting 38,980.5. Now we will
I'm
get
still
when
solving 1 second.
we'll solve it. Okay.
I got 38980.5.
Okay, good. Now this is the amount, Sunil. This is the amount. Now what will we do? How to find the CI? CI is equals to A minus B. Okay. So calculate 38,980.5 minus 32,500. Subtract it.
Excuse me, ma'am. Which question is this?
This is Simran practices some extra questions from the ICSC book. Okay, so this is his out from that.
Oh,
Yeah,
I got 6480.5.
6,480.5. So this is your interest. Okay, right approx. Right, 6,480.5 is your compound interest. All right. Hope it
I got
is
the same
clear.
answer when solving it before, but in the answer key of this book, it's saying 6482.54 is the answer.
6,482.54 is the answer. Okay, I'll tell you why is that coming. So when you are doing the cube of 1.0625, when you are doing its cube, you will get a much bigger number. Okay, 1.1994, we took it till 4 decimal places. I think you are getting a number which is up to 6 or 7 decimal places. Okay. Yeah, so he took that number that is up to, like mostly Simian, we take the number till 3 or 4 decimal places we take. Okay. But some are bigger, that is still 6 or 7 decimal places. This answer was coming here. So that thing he multiplied with this here, and then he was getting some amount. Okay. That time he was getting some amount, and then he subtracted the principal from it. Okay, and then he was getting a number which is like two numbers more than this one. So that is how the little bit difference is coming. But this is okay, Sanil.
So
Okay,
this is also
but
correct.
this is also correct, Sanil. Yes,
Okay.
yeah,
Okay,
because
thank
method
you.
is the same. Yeah, everything is the same. Only we took it to 4 decimal places, so it is also considered correct. Right? Yeah. Okay. Now let's begin with the science class, guys. Cameras on, everyone. One minute. Yes. So we were studying about crop production chapter that we had begun, and crop production chapter we talked about various types of crops. Okay, we talked about monsoon crops, winter crops, and seasonal crops. And today we will talk about planting the crops. Okay, today we will talk about planting the crops. Now, when a planting of crops takes place, it is a process. Okay, it is a process, and the process starts with preparing the soil. Okay, because in the soil only we plant the crop. Okay, plant the seed in the soil or the small plant. Before that, we need to make the soil ready for that plantation. So step one is preparing the soil. Then a lot of things are there like sowing the seeds, making compost, splitting fertilizers, then irrigation, weeding, lodging, etc. Okay, so we will talk about all of that. Okay, the steps that are there in the process of planting crops. So the first thing is preparing the crops. Now, farmers, what do? They check the soil, okay, first for preparing it for farming. Okay, they check the soil that if the soil is good for that kind of crop or not. This checking can be done at the checking center of village or blocks by giving the sample of soil. This lets us know the type of soil and which type of crops suits the soil. Okay. There are various kinds of soil, okay, like red soil, black soil, loamy soil, sandy soil. Okay. Soils are also of various types. And for particular crops, particular type of soil is required. Okay. You cannot grow any kind of crop in any soil. Okay. Because it might not suit that crop, that soil. So that identification of soil, the checking of soil is done to know which kind of soil is it, okay, and which kind of crop can be grown in that kind of soil. Then, after checking of soil, one starts working in preparing the soil for farming. The top level of soil is dug about 6 feet deep. This soil is known as humus. This humus includes decomposed organic items made up of plants and animals. So 6 feet is dug, okay, and this soil is known as humus. Why? Because it includes the decomposed organic items made up of plants and animals. These decomposed items are changed to compost known as humus. Okay. This is enriched in minerals which are beneficial for the plants. This is how to create humus, okay, an activity on how to create it. Get soil from the nearest garden and place it in a glass, add some water and mix it with spoon. Keep glass for some time. What do you see? Some mud is seen on the top level of glass. This is humus, okay? This is how humus is prepared. Humus we can prepare and see for ourselves. Now,
Isn't that because the fertilized soil is much lighter than the other soil?
fertilized soil is much lighter than the other soil, yes, and because it's also because it has decomposed organic items in it.
But won't
Okay,
that make it heavier?
won't that make it heavier? No, it won't make it heavier because that is completely decomposed in the soil. Okay,
Okay.
no remains. Yeah, no remains, completely decomposed. Now, you know very well the need for soil preparation. Let us know how soil is prepared. First of all, soil is made hollow. Now the question is why the soil is made hollow. There are two causes of it. Okay, why the soil is made hollow? Two reasons. First, hollow mud keeps nutrients going deep into the roots of plants. Many minerals, water, air, microorganisms, and earthworms are found in soil. Microorganisms and earthworms grow fast in hollow mud because they get air and water in full quantity. These microorganisms and earthworms make land fertile. Traces of dead plants and other organisms are also found in soil. Okay, now we know that in soil, the dead plants and animals are broken down in soil by microorganisms. Okay, they are broken down by microorganisms to form soil. Thus, this decomposition mixes many nutrients in the soil. These nutrients are absorbed by the roots of the plants. Okay, so what is happening? Why is soil made hollow? Okay, now there are microorganisms and earthworms in that soil. When it is made hollow, air can get in the soil more easily, and water can also get to them more easily. Now, when air and water gets to them, they help the microorganisms and earthworms to grow faster. Okay, there it is helpful for their growth. Now, when the microorganisms
I
and earth, yes, Samir.
I didn't understand what you mean by hollow soil. Like, is each grain in the soil hollow, or is it like a hollow area with lots of mud covering it?
Some holes are made. Suppose this is the surface of the soil. Okay, this is the surface of the soil, and holes are made like this.
Okay, now I understand.
Okay, it is made like this, and now earth forms and what I was telling, yeah, microorganisms are there beneath that soil. So when the holes are made, air and water can get to them faster and easier. Now, with through that air and water, they grow much faster. It helps them to grow faster. And now, various animals die on the land, and plants also they die on the land. So microorganisms eat them up, okay, and helps those dead remains to become soil, okay, to become soil, and then the nutrients are absorbed of those remains in the soil, okay. It is absorbed in the soil. Now, when the plant is planted here, when the plant is planted here, what happens is the roots they absorb those nutrients. Okay, the roots will absorb those nutrients, and the plants get the nutrients. Okay, so this is why it is important to hollow the soil to create the holes in the soil. Okay, I hope this first reason is clear. Now we will move to the second reason. Let's read about it. Secondly, roots are deeply inserted in hollow mud. Roots can easily breathe. This helps in the growth of plants. Therefore, making void space or mud or space in mud is very important in agriculture. This helps in bringing the nutrients on the top layer of the soil. This helps in this helps the plants in absorbing nutrients at fast pace. This is done by plow and tractor. Okay, can you see these devices? They have pointed edges. Okay, all these things have pointed edges, and these are used. This is attached with a tractor at its back. This thing, okay, or it can be attached with bulls also. Okay, which hollow the soil. Okay, and the nutrients are come on the top layer. Okay, which is then easily absorbed by the roots, which also helps the roots to grow, to breathe. Okay, then this process is known as cultivation. Okay, this thing is known as cultivation of soil. Tractors are used nowadays for cultivation. After cultivation, many loose big balls of mud are left as residue. This is leveled by hoeing. This is done because the equal and uniform soil is required for irrigation and sowing. Then the soil that is unequal, or if it forms some balls kind of things like that, uneven soil balls, okay, then that is leveled, okay, by a process known as that is leveled by hoeing. Okay, that thing is known as hoeing, the leveling of the soil back. Okay, because level soil is necessary. so that the plants, for the uniform growth of the plants. So that leveling is done. Sometimes fertilizers are mixed in soil before cultivation. This helps in better mixing of nutrients in soil. Major tools used are plow, pick, etc. Okay. Then sowing. After the preparation of soil, the next important step is sowing of seeds. It is necessary to choose healthy and clean seeds of good quality before sowing. This is a sowing of seeds. Okay, now our soil is ready. Soil is hollowed, nutrients are mixed, land is cultivated, it is made equal. Now it's the time to sow the seeds. Okay, so first step is we have to choose the seeds. Okay, take some seeds of wheat in a utensil full of water. You will see that some of the seeds will start floating on water. These floating seeds are hollow because of decay. This is one of the techniques to differentiate between good and bad quality of seeds. Okay, now you can try this at home. Many tools are used for sowing of seeds. Okay, let's learn about it. Now there are tools that farmers use to sow the seeds. There are traditional tools, there are modern tools. Traditional tools. These tools are in shape of keep. The lower part of the keep is connected to a three-sided pointed pipe. Can you see this diagram? Three-sided pointed pipe. Can you see pipes here? Here. Okay. And they are attached to the bottom. And this thing, okay, this thing, he is putting in the seeds. Okay. Putting the seeds in. And then it's going to the different pipes and then they are dropping to the soil. Okay, dropping to the soil. So this is a traditional method. Okay, at the time of sowing, these pointed points cut the soil and place the seeds in them. Okay, like they go down in the soil, they make a hollow and they drop the seed in that. Okay, this is the traditional technique. Then we have scattering seeds technique. Seed drill is used to sow seeds at an equal distance. The machine is attached to a tractor. This covers the seeds after sowing them. Thus, the further damage to seeds is stopped. Seed drill takes less time and less labor in sowing the seeds. Seeds are sown at an equal distance so that they get proper sunlight, nutrients, and water. If the distance is less between the plants, then some of the plants are removed from their place. Okay, because one plant grows and covers the other one. Okay, so that is why it's important to grow them at a particular distance. You cannot grow them very close to each other. Okay, they try to outgrow, overgrow each other, and they try to eat up the other one, cover the other one. Okay, and the nutrients also, that there is not equal distribution of nutrients. Like if they are planted too closely, the nutrient of one plant will be absorbed by the other plant. Okay, so that is why they are planted at a distance. Okay, then we have mixing compost and fertilizer. Okay, then compost and fertilizer mixing is done. You must have seen farmers adding something like soil to their land. This is known as compost and fertilizers. Soil provides mineral for the better growth of the plants. These mineral elements are known as nutrients. Compost and fertilizers add nutrients to the soil. That is why it's very important when we are growing crops to add compost and fertilizers, okay? So that nutrients can be provided to the plants and the crops. Due to regular production of crops, nutrient levels get decreased in land. To make up this deficiency, compost and fertilizers are added to the soil. Okay. Now, nutrient levels also sometimes decrease in the land. Okay. To again give that nutrients to the land, the compost and fertilizers are added. Okay. Then compost. Let's talk about how it is made, what it is made up of. Basically, compost is made up of dead decay of plants and organisms. All the decay is decomposed in a hole dug by the farmer. This hole is left open. So microorganisms decompose the materials in the hole. This is now known as compost. Thus, compost comprises of organic items. The water level of land is increased by compost. Organisms and bacteria grow and multiply easily in compost. This hollow mud works as green compost for sorghum, beans, etc. Okay, so a hole is dug, and all the remains of all the like plants and animals is kept in that hole, and the soil is put in that hole. Now, in that thing, microorganisms are produced. Okay, they originate in that thing. Microorganisms and your yeah microorganisms and this and earthworms. Okay, and they start eating that up. All right, and it is decomposed entirely, okay, and then it becomes a compost, okay. It gets mixed up with the soil and gives nutrients to the soil, okay. Then we have fertilizers. There are chemical items which have special nutrients. These are produced in factories. Some of the fertilizers are urea, superphosphate, ammonium sulfate, potash. These fertilizers are used to make the soil more fertile. Okay, to make the
Is
soil more.
potash is similar to potassium or something like that?
Is potash similar to potassium? I'll see similar. Okay. If in this context of fertilizers, is it similar? Okay, or in fertilizers, potash is used. So is it similar? I'll see. Okay. Now, however, so how do they make the soil more fertile? Okay, they can make the soil better for the plants in such a way that plants grow well in that. Okay, fertile means the soil that is rich in the nutrients. Okay, a soil that is best for the growth of the plant. Okay, so however, the more use of fertilizers stop the growth of fertility of plant. Fertilizers should not be used too much. Okay, shouldn't be used too much because they're having chemical items. That is why if too much of it is used, it can be bad for the soil and bad for the crops. Now, plant
What?
decay. Yes,
How does
Samya.
it ruin the soil? Like what in it? What in it is
What
bad?
what in it is bad? Suppose I am using one of these chemicals, okay, and I'm using it too much. So my soil will turn acidic in nature. Okay, like my
Okay.
soil will turn acidic in nature, and then that will be bad for the plant that is growing in that soil. Okay, because soil should be balanced. Like too acidic soil will ruin the growth of the plant. Okay, so
Okay.
that is why, yeah, so that is why fertilizers shouldn't be added too much in the soil. Plants decay to make soil fertile and organic compost. Sometimes time gap is given in sowing these crops. Thus, crops are planted by changing it. Okay. After sowing one crop, a different crop is planted. This is known as rotation of crops of crop rotation. Okay, now what happens? Suppose, I have one crop, okay, one type of crop I have grown in a field. Okay, I have grown, suppose, wheat crop. This is just an example. Wheat crop in this field for 3 months. Okay, now wheat crop I have grown for 3 months. Season ended. Now what will I do? In the same, I will grow maize crop for the next 3 months. Like after growing wheat, for the next 3 months, I will grow maize crop. Okay. So, and after that period has ended, I'll again grow wheat crop. So when this is done, like when one type of crop is grown for a particular period, then another type of crop. Okay, this process is known as crop rotation. Okay, this process is known as crop rotation. Pulses are generally sown after wheat. Okay, after wheat time period of wheat is over, then on that land, pulses are generally grown. Now here is the difference
I
between
read about this
fertilizer. You
because
read about
the wheat takes some nutrients and then lots of other nutrients are left and less of the ones that wheat needs. So another plant is
mhm,
sown that takes those nutrients.
those nutrients. Yes, that is right, Simeon. So that thing where the crops are alternatively planted are known as crop rotation. Now we have the difference between fertilizer and compost. Okay. So fertilizer are made up of inorganic items, that is chemical items, and compost is made up of organic items, that is dead and decaying plants and animals. Okay. Then we have fertilizers, which are produced and made in factories. Okay. Fertilizers are made in factories, but compost is prepared in a farm. This is prepared by the farmers in the farm. Okay. Then fertilizers do not give humus to soil, but humus is given to soil by the compost. Okay. Humus is given by the soil into the soil by compost. Then fertilizers has high quality of minerals. How quality of minerals is found in compost? How? I think it's high. High must be written. Okay. Overuse of fertilizers hampers soil. Okay, means it changes the like pH of the soil kind of. It makes it more acidic. It changes the balance of the soil. Overuse of fertilizers, but compost can be used nicely. It does not changes the like balance of the soil. It does not changes balance in the nature of the soil because compost is created by nature only, by nature itself, by the dead and decaying organisms. So this does not hamper the soil. Then we are having irrigation process. Okay, irrigation process we are having. We need water to live and sustain. In the same way, water is essential for plants to live, grow, flower, fruit, and seeds to live healthy. Plants are composed of about 90% of water. Water is required for sprouting of seeds. Now, irrigation is how do we supply the water to the plants, okay? How do we supply the water to the plants? That thing is basically simple words. That thing is irrigation. Now, the roots of plants transfer nutrients to the plants. We know that how do plants get nutrients? They absorb it from the soil. The roots absorb it from the soil. Root absorb minerals and fertilizers present in the soil. Now, these elements are mixed with water to reach every part of plant. Water saves plants from chill weather and hot air. Water is given to plants from time to time for better crop and to retain moisture in soil. Okay, so that moisture is there in the soil and so that the plant growth is healthy. This activity is known as irrigation. What is the time of irrigation? How many times irrigation should be done? That thing is dependent on the plant, on the crop, its quality, okay, its soil, and the weather. All right, if it is rainy season, we will not go to water the crops 3 times a day. Right, if it is rainy season, we will not do that every day. We will not plant the crops. We will not water the crops 2 or 3 times because rain is also coming in every 1 or 2 days. Okay, so that time we water the plants less. Okay, and if the soil is too, the soil quality, if it has too much of water in it already, and then we put more water. If we give more water, if the soil has already moisture in it, lot of moisture in it, and we keep on watering it, then soil
It will take the place
particles
of
will,
air.
yes, it will take the place of air, and the soil particles will also loosen. Soil will open like this. Particles will loosen. So, how much to water the plants? Okay, when to water the plants? That is dependent on what is the weather, what is the quality of the crop. Okay, does it need too much water? Can it survive in less water? And what is the quality of soil in which that is grown? Okay, now irrigation is required more in summer than in winter. Okay, we know that in summers plants need more water, so irrigation that time in summer seasons it is requires more. You must have seen many methods used by the farmer for irrigation. Let us see which are those methods. Nowadays, new techniques are also used with traditional techniques of irrigation. Some are the traditional techniques that have been used for ages. Some are new techniques that are used nowadays. Yes, Amir.
In Egypt, they used shadaf in
Okay.
ancient Egypt.
All right. So, how does the irrigation takes place in that method?
It's like a type of seesaw that can be turned around like 360, and then one side has a weight and the other side has a kind of bucket, and then you push, the person will push the weight up so that the bucket goes into the river, and then he will let go and the weight will come down and the water will come in the bucket. Then he will turn it around and empty it into the soil.
Okay. Okay. All right. That is interesting method. Then,
I also read about it.
I have a question about the method. Why doesn't the person just put his hand inside the river and take out the water?
Because there was a big field, so he needed to take more water. He can't just keep on putting his pail inside every like 100 centimeter to put the water. So he
Exactly.
used the
Like
shadow to take more water.
a
So then how
farmer is
many buckets are there on this wheel?
One bucket, but a large one.
So then how does he carry it to the crops? Like, is there a system for that even?
The crops are right next to the river.
okay. All right. So, we'll talk about some traditional methods. Now, water is sent to land by means of well, canals, etc. Other methods include mods, chitney, stream pump, etc. These methods use pump to pull water from the land. Diesel, biogas, electricity, and solar energy are used to drive the pump. Okay, so these are some methods. This is what Simeon, this is what it must have looked like, right? I think
Yeah,
so.
kind of like this, but it was bigger, much bigger,
Much bigger, much bigger. Yes.
like
So
10
this
times the
is
size of this, so they can carry lots of water.
okay. Yeah, this is the seesaw kind of thing that method Simeon explained. Then there are chain pumps like this. Okay, and wells are there. Wheels are there, okay, to carry, to pull up the bucket from the well, and then they take it for to do the irrigation. But these are like traditional methods. Now we have modern methods. We have sprinklers. You must have seen in gardens and fields. I hope you guys have seen the sprinklers.
yeah.
Yeah,
Yes, yes. So these are yes, Anara.
No, sorry, mama. I was trying to switch on my video.
Okay. So now, what are sprinklers? Basically, they are vertical pipes which are used in this technique, which have nozzles on the top of the pipe, which move in a circular motion. These pipes are joined to the main pipe at a particular distance. When water is sent from the main pipe with the help of pump, it comes from the nozzle, moving in a circular way. This water is sprinkled in a way as if it is raining. This is more useful in desert soil and imbalanced land. Okay, This is sprinkler.
I have a question, ma'am, about the sprinkler.
Yes.
Ma'am, the reason the sprinkler moves, like the top part of the sprinkler moves around and around and around, is that because of the water pressure, or is that because there's a motor underneath that?
It's a
Is it
circle.
because of
There's a circle that rotates, and in the sides of the circle there are notches. Each of those notches, when the water is pushed hard, each of those notches send the water in a different way. And every time the circle turns, like it keeps on turning, water can go everywhere.
Excuse me, but I'm asking, ma'am, what does this turning, the water or the motor?
I think it is some kind of motor that is fixed in that, some rotating kind of thing that moves it. Okay, because water pressure cannot like move it on all circular direction directly.
Only the circle turns, the water does not turn. It pushes the water in different
Yes.
directions.
Yes, the circle is turning by a mechanism of the pipe. Okay, Abraham, and that circle when it turns, it pushes the water in different directions. Okay, then in up in different directions. So those are sprinklers. Then we have drip system. Okay, now what happens in this? I have seen this actually. Pipes are
I
laid.
did an experiment with this, like I made a mini model of it.
You made a mini model of it.
Yeah, there are
Okay,
many
what?
pipes with holes in the bottom, and then when water is going through it, the water will keep dripping.
Yes, the
And
water will
according to
keep
the
dripping.
size of the hole, you know how much water is going to drip and at what time, at regular
That
intervals.
is
Ma'am,
that is right. Yes,
ma'am,
Abraham.
my father has a drip system, ma'am, in his office. So, like, if he's out on a he's on a holiday, or if he's not, if he has to, if he cannot go to the office, he can he can on the drip system from the phone, and it automatically starts watering the plants, and he
Yes, that is
choose the
right.
amount of ml.
That is right. So we have pipes, and in pipes, holes are there, okay, at a particular distance. After a particular distance, holes are there, okay, and from that hole, water drips slowly, slowly, not at a very like high speed, but slowly, slowly, the water is
Because
dripping
if it
from
goes
the
too
holes.
much, it will fill the like hole.
Whole field, yeah, it will cover the whole field. So slowly, slowly, water is dripping and then going in the land, okay, going in the soil. So this is the drip system. Yes,
Ma'am,
Abraham.
once when I tried to make a drip system, I cut holes into the pipe, but the water didn't ever reach the top of the pipe. It didn't even reach the pipe.
Didn't even reach the pipe.
The
Okay, so you
motor was
can,
so weak, it didn't even let it go up.
okay, so you can take suggestions from Simeon how to create that model.
And now
Okay.
after this, I took another piece of pipe and I put like a rubber bong and a metal rod, and then I was seeing water was coming out of that metal rod, but then it got rusted.
Then it will get rusted because it is there in the water. So yeah, it will get rusted. Okay, no problem. You can try it out again. All right. So we stop here. Separating weeds, that is weeding and lodging process, we'll study tomorrow. Okay. Monday is your this thing. What is that? The teach
Teach
back
back.
session. Yeah, teach back session is on Monday. So
That day, is there any science class?
no science class that day.
And it's the
Okay.
same time as this, right?
Same time as this. Yes.
There's math
But
class?
ma'am,
Math class, I'll let you know tomorrow if there's a math class. Okay.
Okay.
There's a math class, I'll let you know tomorrow. Yes, Anand.
Ma'am, you said that it could go for over an hour, right? The science class because of the teach back session.
Yes, to not keep a math class that day. Okay, just the teach back session I'm thinking of. All right, so that we can cover it up in our time of the classes. Okay, what's that, Abraham?
Just some
Okay,
class subject.
last option. Okay, then see you guys tomorrow. Bye, everyone. Bye.
Bye. Thank
Bye,
you.
ma'am. Thank you.
Bye, ma'am. Thank you, ma'am.
Okay,
Bye.
bye. Bye. Bye.